Targeting TAKS objective number 6. The student will demonstrate an understanding of geometric relationships and spatial relationships. Problem number 1. Paul is using all the fencing from his square garden to enclose a circular garden around his oak tree. The square garden had an area of 484 feet squared. Approximately what will be the length of the radius of his new circular garden? We want to start here with the formula for the area of a square. That formula is area equals the side squared. The area here is 484 feet, so when we substitute that in for area, we have 484 equals s squared. Now in order to solve this equation, we need to take the square root of both sides of the equation. Normally you would have a plus or minus in front of the square root of 484. However, in this problem we are talking about the length of something, and length is always positive. Let's use our calculators to take the square root of 484. So the square root button is above the x squared button, so do second x squared. Type in 484 and close your parentheses and press enter. So that the square root of 484 is 22, and when you take the square root of s squared, you just get s. So the length of each side of our square garden would be 22 feet. Now you need to draw a square and label each side of your square 22 feet. Your square should look like this. Because the problem tells us that we will be using all of the fencing from the square garden to enclose the circular garden, we're talking about perimeter. So to find the perimeter of this square, you add the four sides together. So 22 plus 22 plus 22 plus 22 gives us 88. You could have also just multiplied 4 times 22. Either way you did it, the answer for the perimeter would be 88. The perimeter for a circle is known as circumference. So the circumference of our circular garden would also be 88. Now you need to look on your TAKS formula chart to find the formula for the circumference of a circle. There are two formulas there. However, since we're asked to find the length of the radius, the formula that you need to choose is 2 pi r. So 2 pi r would equal 88. Now let's solve the equation for r, because that's what the problem asks us to find. To do that, we want to divide both sides of this equation by 2 pi. And that gives us r to be 88 divided by 2 pi. So let's go to the calculator and do 88 divided by, and 2 pi needs to be placed in parentheses because you want to divide 88 by both 2 and pi. The answer we get here, you can see there on your calculator. Now look at your answer choices. The best answer would be choice A, 14 feet. Problem number 2. The perimeter of the isosceles trapezoid shown below is 38. What are the lengths of its bases? Remember that in a trapezoid, the bases are the parallel sides. All that we are given here is the height of this trapezoid. Notice that the height forms a right triangle, and it's a special type of right triangle. It is a 30-60 right triangle. So what we need to do is to examine the 30-60 right triangle. On this right triangle, the side opposite the 30-degree angle is x. The side opposite the 60-degree angle is x on the square root of 3. And the hypotenuse, the one across from the right angle, is 2x. This relationship holds true for all 30-60 right triangles. Now let's go back to the triangle in our trapezoid. What we were given is the height, 3 square roots of 3. Since that's across from the 60-degree angle, it is x on the square root of 3. That means that the value for x in this problem is 3. Here is our 30-degree angle. So the length of the side opposite that would be 3. The 3 represents just that small portion of that base. And the side opposite the right angle is 2 times 3, which is 6. Since this is an isosceles trapezoid, the legs have the same length. So this leg here is also 6, and notice that we have the same height on this side of the trapezoid as well. Therefore, this portion would also be a length of 3 units. Now we're ready to start writing an equation. Here is one base. We're going to call the length of this base A. And then the portion of the base above it will have the same length A. We are told that the perimeter is 38 units long. Remember that perimeter is the distance around a figure. To find that, it's often best simply to add up all the sides. So when we add the sides here, we're going to have 6 plus, the base is 3 plus A plus 3 plus 6 plus A. And that added together gives us a value of 38. Now we want to solve for A. When we do that, use your calculator to add your 6's and 3's together. We want to use the calculator here for calculations so that you'll be less likely to make a mistake. So when you add your 6's and 3's together, you get 18. A plus A is 2A is equal to 38. Now use your calculator to subtract 18 from both sides so that 38 minus 18 gives us 20. Divide both sides by 2, again using your calculator, and you find that the value for A here will be 10. And taking that back to our trapezoid, this portion of the base would be 10, but you need to add the 3 and the 3 together. So this entire base would have a length of 16. The other base is A, and we found the value for A to be 10. So the problem asks us to find the lengths of the bases. That would be answer J, 10 and 16. Problem number 3. Laura and Amika live equal distance from the school. Laura lives directly north of the school, while Amika lives due west of the school. The girls live 12 miles apart. Find the approximate distance Amika must travel to reach school. Since Laura lives directly north of the school and Amika lives due west of the school, what we have here is a right angle. Therefore, this is a right triangle. There is a special relationship of the sides in a right triangle. That relationship is called the Pythagorean theorem. The Pythagorean theorem states that the sum of the squares of the legs of a right triangle equals the square of the hypotenuse. Most students remember this relationship as a squared plus b squared equals c squared. This formula is located on your tax formula chart. It tells you in the problem that Laura and Amika live equal distance from the school. Therefore, these two legs will be the same length. We're going to call them x. In our problem here, x is going to represent the legs of both of the sides of the triangle. So what we have here is x squared plus x squared. The 12 represents the hypotenuse of the right triangle, so x squared plus x squared will equal 12 squared. Now we want to solve the equation. When I add x squared plus x squared, that value would be 2x squared. And 12 squared is equal to 144. You can use your calculator to find that value. And again, you can use your calculator to divide both sides of this equation by 2, and you find that x squared will equal 72. In order to solve this equation now, we need to take the square root of both sides. Now let's use our calculator to take the square root of 72. Remember that the square root button is above the x squared. So we have to do second square root 72 and close your parentheses and press enter. The problem asks us to find the approximate distance Amika must travel to reach school. The answer we got is approximately 8.5. So our correct answer here would be C, 8.5. Problem number 4. A spotlight makes an angle of elevation to a plane of 45 degrees. The distance from the spotlight to the plane is 728 feet. What is the approximate altitude of the plane? Remember from geometry that altitude is the same as height, and that the height is always perpendicular to the base. Here we have a special type of right triangle. It's known as a 45-45 right triangle. There are special relationships between the sides of this triangle. Since the two angles are the same, the two legs of the triangle are also the same. We call both of those x. And the hypotenuse, which is across from the right angle, is x on the square root of 2. Now let's go back to our right triangle. The sides opposite the 45-degree angle are going to be called x. And 728 will be the same as x square roots of 2. So our equation will be x times the square root of 2 equals 728. To solve for x, we need to divide both sides by the square root of 2. And now it's time to use our calculator. So put in 728 divided by second square root 2 and close your parentheses, press enter. So they ask for the approximate altitude of the plane. So x is going to be approximately 515. Therefore, the correct answer will be J. The calculator skills targeted for Objective 6 are the use of the pi key and using your calculator for all calculations to avoid making mistakes. You must know your right triangle relationships for Objective 6. Those relationships are your Pythagorean theorem, your 30-60 right triangle, and your 45-45 right triangle. And this often involves using your square root key. This concludes Targeting TAKS Objective number 6. The student will demonstrate an understanding of geometric relationships and spatial relationships.